Synthetic examples. The synthetic examples presented below illustrate application of the method for imaging two kinds of objects: a point diffractor, which can be considered as approximation of a small quasi-isometric source, such as a small karstic cavity, and a linear diffractor, roughly approximating an elongated source, such as a tube or a tunnel. The model in the first example includes a point diffractor located at a point with the coordinates x equals 40 meters, y equals 10 meters and z equals 10 meters. The medium is assumed to be homogeneous with a velocity of 1000 meters per second. The modeling was performed using a simulated acquisition system represented in. The system included 2 receiver lines with 48 receivers on each line and 5 source lines with 48 source points on each line. The source and receiver spacing along the lines, i.e., in the x direction, was 2.5 meters. The distance between the source lines was 5 meters and between the receiver lines 20 meters, so that the area covered by the system was about 120 meters times 20 meters. Using this system, synthetic seismograms of diffracted waves were computed for each source position, given the total of 240 shot records with 48 traces in each record. Then, a spatially uncorrelated random noise with the average SN ratio of 0.03 was added to the seismograms. Represents an example of one of the records. Due to the low SN ratio, no traces of diffracted events were identified on the record. Source receiver geometry used for a point diffractor modeling, plan view. Point diffractor model, an example of a synthetic record. A and B represents the results of the point diffractor imaging with a velocity of 1000 meters per second. A shows 5D sections computed along the lines defined by the Y values of 0, 5, 10, 15, and 20 meters. The sections display a well-defined anomaly whose maximum is located at x equals 40 meters on the section with y equals 10 meters. The amplitude of the anomaly is rapidly attenuated away from its maximum in both the x and y directions. This can be seen even more clearly on the D map, B. The figure shows that the diffraction anomaly is very well localized on the xy plane around the imaged point diffractor. A. Point diffractor model, D sections and, B. Point diffractor model, D map. The model in the second synthetic example contains a linear diffractor, which can be considered as a set of densely spaced point diffractors. The diffractor crosses the x-axis at the distance of 40 meters from the origin at the angle of 30 degrees. The model parameters and the acquisition system were the same as in the previous example. Source receiver geometry used for linear diffractor imaging, plan view. The D sections obtained for this model with a velocity of 1000 meters per second, A, display a well-defined anomaly whose location on the sections varies along the y-axis in accordance with the inclination of the imaged linear diffractor. This is further illustrated by the D map, B. The map shows a prolongated quasi-linear anomaly whose location and inclination on the xy plane correspond well with the imaged linear diffractor. A. Linear diffractor model, D sections and, B. Linear diffractor model, D map.